Hi, my name is Emily Herbert, and I was assigned for discussion week 11, number 24, find the dot product of two vectors. I'll be up front. I just started the vector section of chapter 6, so I'm going to do my best to explain this. Okay, so I just kind of pulled this from the book. The dot product of two vectors. The operations of a vector addition and scalar multiplication result in vectors. By contrast, the dot product of two vectors results in a scalar, a real number, rather than a vector. Okay. So, definition of a dot product. So here we have the one vector, second vector. The dot product of those two vectors. Here's the format of the formula. The dot product of the two vectors is the sum of the products of the horizontal components and their vertical components. Okay. So I got this kind of from the homework. I love homework. It always helps me. So so I got these two vectors, B and W, and we need to sort of plug in those vectors and fit into this sort of formula or this definition. So I kind of enlarged this just to show you what A1 and A2 and B1, B2 were in accordance to these two vectors that were given. So here's the first vector, and that is going to be A1, and its second vector, its little buddy, sister here, A2, and then there's B1 and B2. So we're going to plug those coefficients of I and J into this definition here. So that's what I do down here. I find V, the product of the vector V and W, and that's where I get 6 times 1 plus B1 and B2. So 6 plus 6 equals 12. Alright, and then we can also just multiply the two the vector V by itself, vector V times itself. So two vectors, V and B. So it would have been, this would have been vector V times vector V. So we got A1, 6, A2, if this was just copied over, A2 would have been 6, you get the drift. And then we got B1 and B2, 1. And then 6 times 6, 36, plus 1 equals 37. And that's all I got. Alright. This will be posted along with the discussion. Thank you very much. Happy Halloween.